Namaskar, welcome to Prakash on Basics. I am Prakash Zog, and we've been talking of the beautiful world of colors. I was explaining how colors mix with each other and produce a variety of other colors that we know of, primary and secondary and tertiary and so forth. And I told you that there are different models for it. We talked of two models. We are now looking into the more common and more commonly used model nowadays. This is the third model. It is known as the CMY model. Like last time RGB, this CMY represents three colors: cyan, magenta and yellow. So, it is the cyan, magenta, yellow model that we are going to talk of today. It is I told you that some things and some interpretations are a little confusing as far as colors are concerned. We are coming to that confusing but interesting part. This particular model, the CMY model, is a subtractive model. What it means is that when white light falls on any particular pigment or dye or paint or an ink, then a part of it is absorbed and the remaining part is reflected back, and the reflected part is the one that you particularly see. This is what we discussed when I even mentioned about chlorophyll, where when light falls and then what you see is that particular color, or when you see a particular color like this one or this one, any one of them, it is that particular color that is getting reflected and all the others are getting absorbed. That is the basic logic of how subtractive colors work. In this particular case, cyan, magenta and yellow are the three primary colors, and using these three primary colors, it is possible to produce the primary colors of the RGB model. That means they can produce red, green and blue, all three of them, but they are originally cyan, magenta and yellow have been produced because of RGB. See, so now things are going to get a little complicated when you try to interpret them. This particular CMY model, using the inks of this particular model, when color printing started in the early stages, when color laser printing started or photographic printing started, it is this particular technique or this particular model or this excuse me, this particular process was the one that was used. This combination was the one that was used to produce the necessary colors. We talked of the RGB model last time. You need to relate these two because there are a lot of things that are common between the two of them and they are complementary to each other. To understand this, I'll show you a diagram drawn by me, obviously. Copyright issues, so let me not get into that hassle and show you diagram that I have made myself. You have to stretch your imagination a little bit to try and understand what I have written or presented before you. I will try and make sure that you can see it clearly. I might have to change the angle a bit. Yeah, I think that should be okay. It is the model that it is the diagram that you need to see. My face isn't all that worth seeing, so let us keep that aside. Okay, so what you have is the CMY model and the RGB model, both represented side by side. Both these models are complementary to each other. One RGB is an additive model. It uses light sources for it to work, whereas the second one, which is the CMY model, is a subtractive model. It requires pigments and paints and dyes and inks and so forth, and it is through them that you can interpret this particular model. The beauty is that the primary in one is the secondary in the second case. and vice versa obviously. RGB, when all three of them are mixed in equal proportion, results into white light on the screen, that as I mentioned last time. While CMY, when you mix all of them together, what you get is, ideally you are expected to get black, but it really does not work out that way, and it turns out to be muddy, darkish brown color that you tend to get. One of them is used to show the effect on a screen, whereas the second one, CMY, is used to print on paper or on the screen printing, etc., that we the screen flexes that we see and so forth, not screen printing, sorry. And all of them, rather both of them, use white background as their requirement for best results. So you can see the way in which they combine. Question is, we talked of green and red combining to give yellow, green and blue combining to give cyan, red and blue combining to give magenta. But we need to find out how, if these are the ones that are already produced, how can they recombine and produce different colors, as it is shown under a CMY model, where you have yellow and magenta combining to give red, yellow and cyan combining to give green, and cyan and magenta combining to give blue. How does that happen? It is this that could be a little tricky and confusing to understand. Let us try and do that, because it is pretty interesting to see how it works out. Let us say they are all three of, like last time on a white paper we print them in pairs and then in overlapping situations, and see how and try and interpret how this information works out. CMY, all three of them, cyan, magenta and yellow, are all absorptive, and they can produce, as I said, R, G and B. That is what we need to interpret. We have to look at it from two different angles. What CMY is made up of in the first place, and then what happens when they combine with each other. Let us say we look at magenta and cyan. Magenta is made up of red and blue. Cyan is made of green and blue. So both have blue common in them. This is something that we saw in the chart. I will put that up again once more, so that it should not be very difficult to simultaneously look into. So now suppose we quote both of them and one on top of other, what would happen is both of them are not going to absorb blue, because that is a common factor between the two of them. So it is the combination that is going to result into blue once more. So magenta and cyan will combine to produce or transmit blue light, and each of them will absorb the other part of the other one. Let's look at another possibility. Look at the RGB combination. How do we get yellow? It is made out of green and red. How do you get magenta? It is produced out of blue and red. For both of them, red is common. Now if I have yellow and magenta painted on top of each other, let us say partly, as you can see in the diagram, then for both of them red is common, that will remain unabsorbed, while magenta will absorb the green in yellow and yellow will absorb the blue in magenta, but both of them will keep on transmitting red. So naturally red is what will be seen. So if I print yellow and magenta inks or dyes on each other, the result is going to be red. Please think over it very carefully and try to look at the logic on your own and make sure that you have got it clarified. Let us give it another try. Let us say I talk of yellow. In RGB model it is made out of red and green mixture, and let us look at cyan. Cyan is made out of blue and green in RGB model. So, we know how they are made. Now, suppose we over paint one on top of the other. So, if you print or paint them on each other, Y will absorb blue from cyan and cyan will absorb red from yellow, and so you will find that in the combination green will not get absorbed. So, naturally when they are painted on each other, what you would have is green. So, yellow and cyan when painted on each other is going to result in green. So, that is how these combinations seem to work out. Try and work it out once more on your own. It is not very difficult really. You just have to keep all those three figures in front of you or in front of your mind and see what is common. Whatever is common is the one that is going to remain, the rest of it is going to get absorbed by each other. So, if all three of them are overlapping, naturally they will absorb each other and nothing will be left. That is what exactly happens. Now, suppose in this combination I change the percentage of either yellow or cyan or magenta as and when desired, then naturally I am going to get different combination. So, if the percentage is changed when yellow and cyan are printed on each other, what I would get is green and all its shades. When percentage of yellow and magenta is changed, then I will get red and all its shades or tints obviously, and when cyan and magenta and their percentages are modified, the combination will result into blue and all its possible shades. So, that is how you get a so large number of colors that are available in this process. The gamut of this CMY combination is pretty big. So, during printing as required, I have only one or two of them overlapping in small values, or if you want to have additional different shades, you add the third one in a different percentage to a small or less extent, and then all the gamut of colors, which is far greater than the original red, yellow and blue, can be obtained with this CMY combination. So, nowadays even painters to some extent tend to use this combination as a more effective method of getting color combinations. And if you do not paint anything, the background is still white. So, you get the necessary white as and where required, all three, and ideally you are supposed to get black. So, CMY in these recent years was used by all the printing processes and color photographs and all these laser printers in the beginning and so forth. But with time some problems became quite evident. To print black, too much of ink was required. So, all three of them, which are pretty costly, were to be wasted and used up. And as it is, the combination did not give you perfectly black, it only gave you muddy darkish brown, which was not really perfectly black. The second issue was the cost of printing all three of them was a bit more, because you are going to use three overlapping inks to try and manage and get black. So, the cost increased. Thirdly, when you are going to print three particular inks mixed at that particular point, it is obviously going to take a larger time to dry, and so the processing is going to take longer time. So, all this meant that it was not really very time convenient to use these, and neither were you getting what you wanted. There was one more issue. All text printing that is done on usually white background is usually in black, and printing in pure black gives more fine detail, and also black ink is the cheapest in the whole lot. So, the Germans thought of this very conveniently and found out that it was not economical to use CMY combination. So, they added a fourth color to it, and in German coal K represents coil is coal basically, which is black. So, they added a fourth color which was black and used the word K for it. Unluckily, nowadays everywhere people will talk of the fourth pattern as the most recent one, which is known as a CMYK, and they would say that K is key, and that key is the black color that is used in the block. So, black was added to make this model more effective, which is now known as the CMYK model. Cyan, magenta, yellow and key, which is black. But why didn't they use the word black itself in the first place? Because had they done that, it would become CMYB, and B could be blue or brown, and that was not what was done. It was pure black, which was coal that was used, or rather pure black. So, that is why CMYK was used. So, the fourth primary for this particular block was added on to make the model CMYK, and this model is the one that is the one that is used nowadays in all these flex board printing and many other situations. There the letters are usually in black, which are very clear, and adding black is very easy to cost wise also, and adding a little bit of black to any of the colors is going to give you all the possible shades, and if you reduce down the percentage of all of them, you are going to land up with all the possible tints, and all the other gamut of colors is available. So, nowadays this is the technique that is used for all flex printing, flex board printing. Our elections are going to be around the corner, and you will see all these boards, and that is how they are printed. So, CMYK and those large scale printers are there, very big ones. So, they can't waste time and wait for it to keep on using all three inks together and take time to dry. You can't do that. So, you use 4 of them and finish the job efficiently, nicely, clearly, and get all the possible combinations. So, as yet this is the technique that is used as far as colors are concerned. So, next time you look at any particular colored chart or any laser printer printout, please realize that this is how the subtractive CMY and the CMYK model are put to use. If you have liked whatever I have said, please like and subscribe to this channel. Try and interpret the information on your own. Tell your friends about it. I am sure you would appreciate the beauty of colors that is all around us. We have been talking of light as an energy form. We talked of bulbs and so many things. But man has been a very intelligent person who can invent a lot of beautiful things, and he came up with what is known as the lasers, and that is the next area that we must know of, because lasers are used everywhere. It's not, we are not really aware as to how many places lasers are used. So, after 15 days when we meet, we will look into the beautiful world of lasers, not just one day but a few more days. Till we meet then after 15 days for this particular new area in light energy. Namaskar.